Through this video, we will learn different type of matrix. But before learning the types, first let us understand what a matrix is. A matrix can be defined as a system of m cross n numbers where m and n can be any positive integer, such that these numbers are arranged along m rows and n columns. For example, if A is an m cross n matrix, then its elements can be represented as A11, A12 up till A1n, A21, A22 up till A2n, and we go up to AM1, AM2 and AMN. The values of m, n and the elements of the matrix leads to different type of matrix. The first matrix that we will discuss about is the row matrix. When m is equal to 1 and n is any value more than 1, it leads to row matrix. For example, A is shown as a row matrix where m is equal to 1 and n is equal to 5. The next type of matrix is the column matrix. Just opposite to the row matrix, here the value of m is anything greater than 1 while the value of n is equal to 1. For example, A is a column matrix where m is equal to 5 while n is equal to 1. The third type of matrix is the square matrix. When m and n are any value more than 1 and are equal to each other, then it leads to a square matrix. For example, A is a square matrix with m equals to n equals to 2. The fourth type of matrix is the rectangular matrix. When m and n are not equal to each other, then it leads to a rectangular matrix. For example, A is a rectangular matrix where m is equal to 2 while n is equal to 3. The fifth type of matrix is a unit matrix, or it is also known as identity matrix. In this matrix, all the elements that are present in the diagonal are equal to 1 while all the other elements are equal to 0. That is, all the elements aii are equal to 1 while all elements aij is equal to 0. The sixth type of matrix is the null matrix. As the name indicates, it is a matrix in which all the elements present in the matrix are equal to 0. The seventh matrix is the symmetric matrix. A matrix is known as a symmetric matrix when all the elements present above and below the diagonal are identical to each other. Or, in other words, we can also say that when the transpose of a matrix is equal to the matrix itself, it leads to a symmetric matrix. The eighth type of matrix is the skew symmetric matrix. When the elements of the matrix above and below the principal diagonal are identical to each other but with a negative sign, it leads to a skew symmetric matrix. Or, in other words, we can also say that a matrix in which the transpose of the matrix is equal to negative of the matrix itself, it leads to a skew symmetric matrix. The ninth type of matrix is the triangular matrix. These matrices can be primarily classified into two types: upper triangular matrix and lower triangular matrix. When all the elements in the matrix lower to the principal diagonal are 0, then it leads to a upper triangular matrix. Similarly, when all the elements above the principal diagonal are 0, it leads to a lower triangular matrix. So this was a quick overview of the different type of matrix. If you have any doubts or any questions, you can raise the same in the comment section. Thank you.